So in this video, we're going to be talking about graphing motions and certain strategies and skills you need to know in order to do some example problems like converting graphs from dt to vt or vt to at, etc., etc. So let's talk about dt graphs right now. Something you should memorize, or not really memorize, but really understand when you're looking at these types of graphs is what means what. What does the slope mean? What does the area mean? What does it mean when the graph has curves, etc.? So we're going to go through that right now. So this is a dt graph, a distance time graph or displacement time graph. It's almost the same thing. So the slope of a dt graph represents the velocity at any point in time. So from here to here, it has a constant velocity of, for example, 2 meters per second. From here to here, it has zero slope, meaning it doesn't have velocity. It's not moving. Same goes with that, but it's just going backwards, and that's just a different slope. The second thing about this dt graph is that if there are curves in a dt graph, then that means the slope is always changing, which means there's a changing velocity, aka there is acceleration. So it's kind of gonna look like that. And in the non-uniform motion video, I talk about how we always assume uniform acceleration because it gets really complicated when we get into jerk and stuff like that. Anyways, now let's talk about VT graphs. So the area under the graph at any point in time is always equal to the displacement. So, the slope of the graph at any point in time is equal to the acceleration. And if the VT graph is curved, this means acceleration changes, which also means there's non-uniform acceleration occurring, also known as jerk, as I mentioned before. Finally, with our AT graphs, acceleration time graphs, the area under the function at any point in time is the change in velocity. So from here, for example, this is 1 second. I didn't really specify because it's just a really brief general graph. But for example, this is 1 second. At 1 second, you changed this much in velocity. You just need to calculate the area of that. And remember, this is all, everything above the x-axis is positive and everything below the x-axis is negative. And if there's a slope, so if there's a diagonal like this, it is the rate of change of acceleration or jerk. Now let's talk about the types of curves in a graph. So firstly, we have an increasingly positive slope, which looks like this. The slope gets steeper and steeper, which means in a VT graph, for example, there's increasing velocity. In this slope, I meant to say DT graph. This is wrong, actually. DT graph, and DT graph. My apologies, that's not right. Anyways, so in this slope, this is a decreasingly positive slope, and in a DT graph, it means decreasing velocity. As you can see, the slope gets more and more closer to zero, nothing, which means it's slowing down, decreasing velocity. Here we have a decreasingly negative slope, so our slope is getting closer and closer to zero, which means it's decreasing velocity in the negative direction. So when we have a displacement time graph, and for example, the position of the displacement is south, when anything that is a negative slope, so here and here, that means it's going the opposite direction, which is north. And finally, in this graph, it's an increasingly negative slope, and in a DT graph, it means it's increasing in velocity in the negative direction. As you can see, the slope is getting steeper and steeper. And here's just another visualization of these types of slopes. So as you can see here, I should have labeled this. supposed to be a dt graph, but it doesn't, honestly, it doesn't matter that much since we're just talking about slopes. So for example, we have a dt graph here, and it goes up and curves and down and then up again. So this curve is really, really similar to our curve like this. This means it has an increasingly positive slope. Right here, it has an increasingly positive slope, and then here it's a straight line, so it's constant velocity. But here our velocity is changing, meaning there's acceleration. This is kind of how a graph looks when you're like driving a car. For example, you're speeding up, and then your velocity stays the same on the highway, and then you slow down, but then you start going backwards and stuff like that. Anyways, this is constant, so we don't need to worry about that. And then this green part here, it is our decreasingly positive slope. It looks like this right here, decreasingly positive, which means a decreasing in velocity, slowing down. And then here we're increasingly negative, meaning we're speeding up in the negative direction. And then constant again, and then here we have finally decreasingly in the negative direction. You're slowing down in the negative direction, which is self. And yeah, that's just the illustration of graphing motion.